Let's discuss about perfect square trinomial. A perfect square trinomial is a quadratic expression which is a product resulting from squaring a binomial. Now we have here two examples of quadratic trinomials, and they are actually perfect square trinomials. So let's consider this 16x squared plus 40xy plus 25y squared. Now, this is quadratic in the variables x and y. Now, how do we know if it is a perfect square trinomial? There are three conditions. First, what the first term and the last term must be perfect squares. Secondly, both the first and last terms must be positive terms, just like this. And thirdly, the middle term must be twice the product of the square roots of the first and last term. Now, the square root of 16x squared is 4x. Square root of 25y squared is 5y. If we get the product, 4x times 5y is 20xy. Multiply it by 2, and that will be 40xy. So that is twice the product of the square roots of the first and last terms. So let's factor this. Square root of 16x squared is 4x. So I'll write here 4x and 4x here. Square root of 25y squared is 5y. So I write here 5y and a 5y here. Now, the sign of the middle term is positive. So, what must be positive here? So, I write here plus and a plus here. So, this is now a product of two identical binomials. So, we could rewrite this as 4x plus 5y quantity squared. So, factoring a perfect square trinomial would result in the square of a binomial. Now, this falls under the general formula. That's a plus b quantity squared is equal to a squared plus 2ab plus b squared. So its literal definition is the square of the sum of two numbers is equal to the square of the first term plus twice the product of the first and last term plus the square of the last term. Now, this is a basic example of a perfect square trinomial, just like this. Now, if we square a binomial, the result would be a perfect square trinomial. So squaring a binomial, or any binomial for that matter, would result to a perfect square trinomial. And likewise, factoring a perfect square trinomial would result in a square of a binomial. Now, let's check if this factoring is correct using this general formula. So that's A is 4x, B is 5y. So using this formula, this is the square of the first term plus twice the product of the first and last terms. Plus the square of the last term. So that's 5y quantity squared. And that's 16x squared plus 2 times 4 is 8 times 5 is 40xy. Plus 25y squared. So it's the same as the given quadratic trinomial. Therefore, this factoring is correct. Now, how about this? 49x squared minus 42x plus 9. First term is a perfect square. Last term is a perfect square. Now, both the first and last terms are positive terms. Now, let's get the square root of this. That's 7x, and this one is 3. So 7x times 3 is 21x. Multiply that by 2, that's 42x. Right there, only it's negative. Now, let's factor this. So square root of 49x squared is 7x. 7x here. Square root of 9 is 3. So 3 and a 3 here. The sign of the middle term is negative. So therefore, both must be negative. So I'll write here minus and a minus. So this is now a product of two identical binomials. So we could write it as 7x minus 3 quantity squared. Now, this falls under the general formula. A minus B quantity squared is equal to A squared minus 2AB plus B squared. So that's the square of the difference of two numbers is equal to the square of the first term minus twice the product of the first and last terms plus the square of the last term. So it's minus because this is a difference. Now, let's check if our factoring is correct using this formula. So that would be the square of the first term. In this case, A is 7x, B is 3. So square of the first term is 7x quantity squared minus twice the product of the first and last terms. So that's 7x times 3 plus the square of the last term, and that's 3 quantity squared. So that's 49x squared minus 2 times 7 is 14 times 3 is 42x plus 9. So it's the same as the given quadratic trinomial. Therefore, this factoring is correct.